In this example, we're going to try the other way to calculate a definite integral with substitution rule. So we're actually going to switch over the limits of integration in this one. So we call this the second method here. So you can do either method. Both methods work. Pick which one you like. So we're going to see how to actually convert the limits of integration. So right now we're going to do this definite integral. It's the integral from 1 to 2 of the function 1 over 3 minus 5x squared. And we're integrating with respect to x. All right, so first thing is we're going to go through our substitution rule and the same first step. Choose u, calculate du. All right, so let's see how this is going to look. We want to choose u and calculate du. Well, we see parentheses. We see this 3 minus 5x all inside this power function. So we're going to let u equal that inner function, 3 minus 5x. So if you see parentheses and there's something complicated inside the parentheses, a lot of times that's what we should pick for u. All right, so once we choose u, then we calculate du. So what's the derivative of 3 minus 5x? Well, that's negative 5. And then we multiply that by dx. All right, so that's the same first step. Now let's rewrite this function. Just to kind of get it into a format that's going to be a little bit easier to integrate. And normally when we have a fraction, well, first thing we could do is sometimes we put the dx's, on the top of a fraction like this. Can be helpful, especially if you're not sure where to go with the problem, to kind of move the dx off of the fraction and put it at the end. So another way to write this is 1 over 3 minus 5x squared dx. That's one thing we could do. And then when we have a fraction here where there's no variable terms in the numerator, well then just rewrite this with a negative exponent. So that's kind of a standard thing we sometimes do to help us with the integration. Rewrite this with a negative exponent. And if we do that, we have the integral from 1 to 2 of 3 minus 5x raised to the negative 2 dx. And so this just kind of, rewriting it like this, really just confirms our choice for u. We have this power function raised to the negative 2. We have a nice set of parentheses here with something kind of complicated inside the parentheses, the 3 minus 5x. And that's what we picked for u. All right. So what we're going to do is we're going to go through and work on just converting everything we have here from x's. Right now all this is x's, and we're going to convert everything into u's. So first of all, the 3 minus 5x, kind of by design, that's going to become u. So let's start writing this in. We're going to have u raised to the negative 2. And what else do we need to do? Well, let's look at what else we have in our original integral here, this dx. Now, we're going to have to do something with this differential. We see a dx, but then we also have this extra constant of negative 5. And we know how to handle if we have like an extra constant, if our differentials don't perfectly match. What we can do is we can solve for dx. That's one thing we sometimes have to do. There's a little bit of work sometimes with these differentials. So divide both sides by negative 5, and we get dx is equal to negative 1 over 5 du. And we see that right here. We can fill in now. We know what dx is. We know dx is negative 1 over 5 times du. So let's fill that in. All right, so we're working on plugging everything in to our integral. So we chose u, filled that in. We calculated du, saw that we had to do a little bit of work solving for dx, but we got it. We filled that in, negative 1 over 5 du. And now what we're going to do is we're actually going to switch these limits of integration. So right now, technically speaking, these are x equal to 1 and x equal to 2 because this definite integral is in terms of x. What we want to do is we want to find the corresponding values for u. And this is where the method is slightly different than the one we just did. So using this substitution, we're going to actually convert the limits of integration. So let's write down our original limits, x equals 1 and x equals 2. And what we're going to do is we're going to plug both of these into our expression for u. So we're going to plug into u equal 3 minus 5x. So when we do that, when we plug 2 in, we get 3 minus 5 times 2, so 3 minus 10. And 3 minus 10 is negative 7. So our top limit was originally 2. It's now going to be u equal to negative 7. And then when we have x equals 1, we're going to plug x equals 1 in. We'll get 3 minus 5. So our new lower limit is going to be negative 2, or 3 minus 5. So we're going to switch those over as well. So our new upper limit is going to be negative 7, and our new lower limit is going to be negative 2. All right, so there we go. We have our limits of integration, and now everything in this integral is in terms of u. So that's step 3, is just substitute all these values into this original integral. And so what we did is we went from this integral here, which was all x terms, and now we have an integral that's all u terms. So now we just go through and find the antiderivative. So integrate this new integral, which is all in terms of u. So the negative 1 over 5 is a constant multiple, so I'll put that first. And then our power function here is in terms of u. So our variable is u. We add 1 to the exponent. We're doing power rule, so we get negative 1. We take that new exponent, flip it, put it in front, so 1 over negative 1. We don't have to use plus c because we're doing a definite integral. And then we're going to evaluate from u equals negative 2 to u equals negative 7. And so when you're switching over these limits of integration, make sure you don't mix up the order. So for x equals 2, that was our upper limit. When we plug it in, we get negative 7. That has to be our upper limit as well. So just make sure you're being consistent. So the lower limit becomes the lower limit. The upper limit stays the upper limit. Just make sure you're being consistent there. All right, so that's step 4, is just get the antiderivative. Simplify it down just to help with the evaluation. So the negative 1 over 5 and this 1 over negative 1, the negatives end up canceling, so we just have 1 over 5. And then to help with the evaluation, let's write this as just 1 over u. So instead of, we'll write this as 1 over 5 times u. Make it a little bit easier. And then we're going to evaluate this from negative 2 to negative 7. All right, so now the last step is just do the evaluation. Whoops. Do the evaluation like you normally would. So the top number goes in first, so we plug the top number in. Negative 7 goes in, we get negative 1 over 35. Plug the lower number in, we get 1 over negative 10, and we subtract. And just cleaning this up a little bit, we don't have to go too crazy simplifying it. I mean, if we wanted to, we could, but that's perfectly fine. 1 over 10 minus 1 over 35. All right, so this is the other method, the other option we have for substitution rule and definite integrals. So figure out which way you like to do it. Do you like to convert over the limits of integration? And that way, once you have your antiderivative, you don't have to switch the antiderivative back to x. So being able to do both methods is helpful, but just decide which one do you like doing better. Do you like converting the limits of integration, and then you don't have to switch over, you can just evaluate? Or like we did in example 1, leave the limits of integration in terms of x and just go through the whole process, get your antiderivative back to x, and then plug in. Personally, I tend to prefer this method, and I tend to see fewer mistakes this way, just because you're just going through the substitution rule process just like you normally would, and then the evaluation just happens at the end once you're done getting all the antiderivatives. But decide which way you like doing it. All right, I think we'll try one more example, so we'll see you there.